Welcome to another episode of the Corrosion Journal interview series. My name is Sammy Miles, and I'm the Managing Editor-in-Chief of Corrosion Journal, AMP's peer-reviewed scientific journal. Today we welcome Ingrid Milošev, Corrosion's newest Associate Editor, as our guest. She is the head of the Department of Physical and Organic Chemistry at Jožef Stefan Institute in Ljubljana, Slovenia, and is also a scientific advisor for Valdoltra Orthopaedic Hospital, where she previously worked for 18 years as the Assistant Manager for Research and Education. Thanks for joining me today, Ingrid.
Thank you for the invitation, Sammy. It's nice to be here and talk to you.
So to get us started today, could you tell me a bit about your background and how you first got into corrosion?
Yes, well, I study at the University of Zagreb, this in Croatia today. I studied chemical technology. So my plan or my idea was to work as a chemical engineering in factory. I don't know really why was that so fascinating to me, but that was the idea. And of course, this turned out to be completely different because I do not work in industry and I do not work in the chemical plant, but I worked in research my whole life. Actually, the break point was at my the third year, the study when I enrolled the electrochemistry class, and I liked this subject very much, also physical chemistry. So in the fourth year, I took electrochemistry as my major subject. Courses there also was a corrosion course in corrosion. So this is my first encounter with electrochemistry and corrosion. And my professor was Professor Mirjana Metikoš-Huković, who I admired very much. And I worked on my diploma thesis with her on passivation of copper. And that was at that time very, very popular subject. And I use many electrochemical methods, and I get to know to this subject, and I liked it a lot. And after finishing after graduation, I moved to Ljubljana. This is now in Slovenia. And I got a position as a PhD student at the Jožef Stefan Institute. Actually, at that time, electrochemistry or corrosion was not an issue they were working on at the Department of Physical Chemistry at that time in Ljubljana. I got a position, but I didn't have instrument to work on, and the subject of my at that time, actually this was master studies. On the master study was corrosion of copper nickel alloys, and these are alloys which are used in nuclear plants. So first thing was to get the instrumentation together, and then this took a while. But then after that, I started working on that, and my master thesis I did on mechanism on passivation and corrosion of copper nickel alloys. And then I continued with my PhD studies at the same institute. And this was a little bit different because I worked on PVD, physical vapor deposition coatings. And this is because there was a department at the Institute, Department of Thin Films and Surfaces, and they were excellent in producing all kinds of PVD coatings. And these are coatings which are very wear resistant, like titanium and chromium nitrates. But at that time, there was a little known about their electrochemical properties or high temperature oxidation properties and so on. So I started to work on this subject. And this took another 3 years. So this was at the beginning of 1990s. And at that time, actually, a change happened that there was a very good collaboration between Slovenia and Germany in the scientific field. And I was very interested to introduce other methods in my research work, other methods than electrochemical methods. And at that time at our institute, we didn't have much facilities on this, like to study the surface analysis of the surface, or to make the surface analysis of the metal. So I applied for this scholarship, and I got a scholarship, and I got a position in the group in Düsseldorf in Professor Henning Streblow's group. So I made most of my PhD in Düsseldorf, working on X-ray photoelectron spectroscopy on these PVD coatings in various environments. It was maybe the most unique laboratory which had the combination of XPS and in situ electrochemical cell. So what we could do is that we could make electrochemical experiments in the chamber, which was attached to XPS spectrometer. And this was built by one of Professor Streblow's former students. So I enjoyed that very much. And actually, I was working in Düsseldorf for the whole 10 years, up to 2002, on and off, but every year going to Düsseldorf, at least for a few months. But of course, my main institute is Jožef Stefan Institute in Ljubljana, where after I finished my PhD and postdoc, I remained there as a steady position, and I'm working there now for 34 years. So, yeah, that's about a little bit about my background at the institute.
That's fantastic. It sounds like you've had an interesting career and have been able to travel around and try different techniques and everything else.
Yeah, I think that's really very interesting, but because you start one thing and then you want to learn something else, and then you go there and learn it, and then you can apply these findings to your to enrich your research work, or to study to make a new research group, or yeah, this is a very important part of a life of research scientist, I think, to go around and try new things.
Right, right. And with that, with trying new things, what are your main technical interests and research?
Yeah, there are several. As I mentioned, I started to work on copper and copper alloys, and I worked to today with these materials, because copper is one of the most important materials in our life. So I would say that the first part of my professional life was mainly devoted to studying passivation and mechanism of passivation and mechanism of corrosion of different metal and alloys. So maybe in the 80s, 70s, 80s, beginning early 90s, it was very popular to study passivation of alloys, or a mechanism of formation of passive film, composition of passive film. These are very exciting things, especially using new emerging surface analytical methods. Also, I worked on pitting corrosion, mechanism of pitting corrosion, and so on. So I would say that the first part of my work was really devoted to these mechanicistic studies, to know about mechanisms, and to know about materials and how they behave, and what type of surface passive films they form, and so on. And then maybe in the second part of my professional life, I devoted more to the corrosion protection. So to work on coatings, on inhibitors, on different type of coatings. So mechanism of corrosion protection. So that would be in short, to explain it. And for me, I think it's always very fascinating to do the research work, but always to have in the background, what is the problem and what is the application this research study will be applied to. So some, so to say, real problem, but for me, this is very important because I think as a research scientist, we have the responsibility to contribute to this general knowledge and development of methodologies which will help to, so to say, to improve our lives or our planet. So this is something which my work is governed.
And,
mhm.
and what do you wish to contribute to corrosion with your technical background? Because you have a diverse set of topics that you've studied over the years.
Yes, maybe exactly this diversity in topics and also methodologies I worked with. I hope I can contribute to, for example, for the corrosion readers or for the corrosion authors to maybe improve their manuscripts, or to give them some advice, or maybe to write some review papers, or to, in a way, get some directions of research, you know, or so. Because I think nowadays corrosion and corrosion protection may be the most important time for it, because now at the beginning of the 21st century, we are in the situation where we are exploring metals we have never explored them. I mean, the production is boosting, so we have to do something to contribute to life extension of metals, and so corrosion protection becomes very important at this point. I mean, we have to preserve the metal resources on our planet. So if we explore the metals without no end, we will finally meet this end. And so we have to, as corrosion scientists, develop methods which will contribute to preserve metals and to extend the lifetime of the metals. So I think this is the goal we all have to tend to.
What are some of the different projects you've worked on during your career? So I know we've touched on some of the technical interests and research and different areas, but what are some of the specific projects?
Yeah, maybe it would be interesting to, for the readers of Corrosion, maybe to touch a little bit the project concerning biomedical application of metal, because usually as corrosion engineers, we think about, you know, bridges, infrastructure, cars, and so on. But rarely we think about using metals in human body. And there are millions and millions of patients walking around with metal implants. These metal implants replace different parts in human body, and their role is to stay in the body as long as possible. So we have to think about what environment of human body, which is quite aggressive for metal, do to the metal surface. And this is a project I started to work on this project in 1996, I think. And for me, this opened a whole new research area, because not only that I then started to work on these biomedical metals I never worked before. These are titanium alloys, cobalt alloys, and medical stainless steel, but also this environment was new. So yeah, this was very exciting, and I worked together with surgeons, and this is always interesting to try to combine these two disciplines, like chemistry or material science and, for example, medicine. So this kind of crossover is quite difficult at the beginning, but then once you know how to speak to each other, how to understand and deal with problems, then it can be very rewarding. So, and this is something would happen here, I think, because I worked together with my medical colleagues for 20 years, and I think we made a lot of nice studies concerning what happens to metal in human body. So yeah, this is interesting, and it is important because it is important for millions of people with implants, with metal implants.
And has your research helped on looking at these implants and what the body does to the metals and working with the surgeons? Has it actually led to any advancements or changes in those implants that are used?
Yes, I think it has really, because together we started with this so-called implant retrieval program. So all the implants which have been removed from body are now not discarded, but we made so to call it an implant bank. So we document all the implants, and we also analyze them as necessary. So we always have these removed implants, to go through, let's say, failure analysis, so to speak. And of course, we also put a lot of effort to include also other samples, like the surgeons, they take tissue and or blood samples from the patient. So for example, in the mid-2000s, it was very popular to use so-called metal-on-metal implants, where you have a metal, for hip implants I'm talking, where you have a metal head articulating within a metal cup. And in terms of wear, this was very promising, because the wear was not, you avoided the wear of polyethylene, which was used as a cup material. So the wear was minimized, but you provoked the dissolution of metal. And we showed in our study that the patients with such implant had increased level of cobalt and chromium in blood and urine. And at that point, our hospital decided to stop using these implants. And very soon, all over the world, actually, these implants were banned from in majority of hospitals because of this. So I think the combination of research studies done by surgeons and material scientists can contribute a lot to the understanding of mechanism of corrosion of metal implants in human body.
Are there any other projects that you wanted to talk about from your career?
Yes, in the last 10 years, I worked on aluminum alloys. And we tried different strategies for aluminum alloys, which are, of course, very complicated because there's heterogeneous alloys. So we worked from corrosion inhibitors to different coatings. In this, this was the late project was financed by last project was financed by European Union. It's called CORROSION. And here we combine these different strategies and also include not only electrochemistry, but we also looked at the different organic molecules, which we synthesized on purpose as corrosion inhibitors for aluminum. And we look at them from experimental point of view, surface analytical, and also by DFT, density functional theory modeling. So this was kind of integrative approach where we combine different techniques, trying to understand how the chemical structure of a molecule affects the absorption on aluminum surface. So I think, and we are trying different strategies, as I said, because nowadays it is important to preserve metals, and so we have to use different strategies to achieve that. So either to be, I don't know, sol-gel coatings, which are, of course, very versatile, and you can synthesize them in different type, composition and thickness, or conversion coatings, which are, again, on the contrast to sol-gel coatings, very thin, or other types of coatings. So I think all these different routes we can take to reach the final goal, and it is to prolong the or to extend the lifetime of a metal, are important. So all my enthusiasm is put into this goal.
It's a good goal. I mean, it's
Yeah, I think
anytime
so.
you can extend the lifetime.
Everything, it's like a puzzle. You make different pieces and put them together, and hopefully you will get the full picture. But yes, yeah, I think sustainable development is something we are looking for.
Mm-hmm. So which of everything you've studied and worked on, what has been your favorite?
Yeah, this is a tough question for me because I like a lot of different things. I like copper alloys, I like X-space analysis, biomedical alloys, I like sol-gel coating. So I would say everything which I like a lot of things, because I think when you work on different subjects, you get this much broader picture of materials and the behavior of materials in different environments. So I like many different things, and I think, and with the goal, as I said, to contribute to metal preservation.
And how has the field changed over the course of your career, and which areas have seen the most change?
Well, the field has changed, as I mentioned at the beginning. When I started to work in the mid-80s, the hot topics were passivation, passive film, surface analysis, and so on. And then I think the major breakthrough is the development of all different methodologies, which really helped us to understand the behavior of metals and alloys. And this can be from microscopies, all different microscopies, to IFM, to STM, to different surface analysis, from, Rutherford backscattering, Auger spectroscopy, down to X-space and synchrotron radiation. I mean, nowadays there are so many methods we can use, explore, to understand the behavior of metals. And I think this is really fascinating. Although electrochemical methods are very, very valuable, and they are in situ methods. So this is also very important, that you can follow and study the metal while corroding, while passivating, and so on. I think this combination of electrochemical methods and other in situ or ex situ methods has really contributed to the understanding of behavior of metal.
And so it's really advanced the field then by having some of the new
I
technologies
think
and blending them.
It's really advanced. Although it's good sometimes to, keep it simple. And you can gain a lot by making a simple experiment. Don't forget that. But on the other hand, it's really nice that we have all these methodologies in hand, and yeah, definitely.
Do you have any advice for women working in the corrosion field?
Well, I don't maybe have exactly an advice for women in working in corrosion, but maybe I can say that I look at this issue from 2 points. One is that there are a lot of women in engineering field, and of course a lot of women at the universities in engineering. And there is absolutely no reason to believe that we are less capable than men doing engineering work. No doubt about that. So just go for it if you like it. If you don't like it, then do something else, of course. But for me, I found my interest in this field. For me, is fascinating. The other thing is, of course, how you can, as a woman, combine your professional life and your private life. I mean, specifically family life. This is probably part of the question. And again, if you really like what you do and you want to achieve something or something more, then I think the main advice would be understanding with your family, because this job or this career or this professional work really takes a lot of time and devotion. So it has to be a lot of mutual understanding between family members. I have 2 daughters. At the beginning, it was very difficult to combine everything because, child really needs you, so you cannot just go for a conference or something. But, everything can be arranged, or at some points, if in your life you work more on other things and you go to conferences less or to travel less or so on. I think that also family has a more rich life if parents are satisfied with their job and they are doing something they really like, and so this is also reflected in children. So it has different consequences. So I think it's all about balance in your professional and private life.
So before we wrap up, is there anything else you'd like to add?
I would like to say that I'm really honored and happy that I became the associate editor in Corrosion Journal. And I hope I will contribute to the team and to the readers of Corrosion. And this is really something I like to work. I mean, to edit and to review. So I hope all the experience I gained throughout the years will help me achieve the best I can.
Well, we're really glad to have you on board as part of the editorial board, as one of our associate editors. So we're really excited to see what you bring, both for our authors and our other editors and staff, and help us continue to improve the journal as we go forward.
Thank you very much.
All right, if any of our listeners want to get in touch with you, what's the best way for them to reach you?
Oh, please send me an email to Ingrid.Milošev. That would be ingrid.milosev@ijs.si.
Fantastic, thank you. And thank you so much for taking the time to join me today.
Thank you. Thank you, Sam.
With that, I'm Sammy Miles, and I'm here with Ingrid Milošev, and thanks for listening to another episode of the Corrosion Journal interview series. If you want to learn more about the journal, make sure to visit corrosionjournal.org. You can subscribe to AMP podcasts if you haven't already on Apple, Google, Spotify, and all the major distributors. You can find all episodes of AMP podcasts on amp.org. That is ampp.org. We'll be back soon with another episode. Thanks for listening.